Hey everyone, welcome back to your math class, and today we're going to jump right into lesson 18, which is word problems involving two variables. So let's get into the plan for today's lesson. So there's not too much that we're going to do today. We're going to look at two word problems that involve two variables. That's to give you guys a little bit of practice before we get into our test review, which will be in our next class on Thursday, and then our test, which will be next Tuesday. So yeah, if we have time at the end of today's class, then you can use that to start studying for the test if you haven't started already. But if you haven't, don't worry about it. You have lots of time. You have another week. So yeah, today we're going to do two word problems, and that'll be all. But before we get into the word problems, I do want to give you a little bit of a heads up about the review sessions. So there's going to be two review sessions for this test, just like there were for the test before this. So the first one is going to be this coming Thursday, which might seem a little bit early, but it's the best, sort of the most reliable time that I can offer that to you guys, that I know that I'll actually have the time for it. So that'll be 8 p.m. to 9 p.m. Dominican time, which for me, I should be in the same time zone by the time Thursday rolls around. So that's just, the Dominican time thing is just a personal note for me. But so I'm going to be in the same time zone as you guys on Thursday, but then I'll be in a different time zone on Monday. So hopefully I don't get my hours mixed up. But at any rate, if there's a reason that I'm not able to make it to one of the two review sessions, I'll definitely let you know. But I will make sure that you guys get at least one, and hopefully both. If I have to wiggle around the times a little bit, I will, but I will keep you posted on that. So yeah, both 8 p.m. to 9 p.m. Dominican time. Again, if it needs to run a little bit over, like if it goes to 9:15, 9:30, because you guys have questions and there's more information that you want out of me, no problem. So yeah, so I will make a review session, or I will host a review session on Thursday evening. I will make a test review video in time for your class on Thursday morning, so that you know exactly what it is you need to study. So hopefully I'll have enough time before that to actually make the test, because then I can make sure that everything that's on the test is covered in the review. But yeah, that's not something for you guys to worry about. So without further ado, let's jump right into the word problems. So you might find that this video ends up being a little bit shorter than most. That's because I want you to have time to study, and I want you to spend enough time thinking about the two word problems that we've got here. So I'm just going to read out the question, and then feel free to pause the video and take a few minutes to work on it. So word problem number one. A young boy spends some tokens on two different games at an arcade. So you can picture like an arcade at a movie theater or something like that. He spends a total of 36 tokens to play 5 games of air hockey and 7 rounds of a racing game. So that's 36 tokens in total. So he's spent 36 tokens, and for that he was able to play 5 games of air hockey and 7 rounds of the racing game. Now the total cost of 1 game of air hockey and 1 round of the racing game is 6 tokens. So that's 6 tokens for one of each. How many tokens did each activity cost? So basically, how many tokens does it cost to play each game once? So you know that to play both games once, that's going to be 6 tokens, and to play 5 games of air hockey and 7 rounds of the racing game is going to be 36 tokens in total. So you can pause the video, you guys can think about it, talk about how you're going to solve the problem. So what I'd like you to do, because we're getting close to the point of the test, is I'd like you to talk about how you're going to solve the problem, and maybe go as far as getting the two equations and get everybody to agree that these are the two equations that we're working with, and then try and solve those two equations independently. That would be just so that you know that you can solve those equations on your own. The only way you can know that for sure is if you solve some of them on your own. So yeah, pause the video, take a few minutes to work on that. You can take quite a bit of time because this is not going to be a super duper long video. And yeah. All right, so here we are. We're going to get right into the solution for this one. So first things first, we do have to remember that we need a let statement because it's a word problem. So we haven't been given that these are the two letters that we're using for our two variables, for our two unknown quantities. So we get to choose those letters ourselves. I've chosen H for hockey and R for racing. So my full let statement is let H represent the cost in tokens of one game of air hockey and R the cost in tokens of one round of the racing game. Now this thing about like the cost, comma, in tokens, comma, that might seem a little bit unnecessary, and in the case of the tokens, it kind of is, but sometimes you'll be doing a question and you'll say, let blah, blah, blah represent the cost in dollars. And again, that might seem a little bit unnecessary, but what if you've got one word problem that's dealing with dollars, maybe dollars and cents, right? So you have to keep track of whether you're talking dollars or cents. And then you've got another word problem that's talking about pesos, right? So you want to make sure that, especially imagine if you have a word problem that's dealing with both of them at the same time. So it's just useful to be as specific as you can in your let statement so that you don't get confused later on, right? Even in something as simple as dollars and cents, if you get a big number like 412 as your answer, maybe you're buying a TV and it costs $412. Maybe you forgot to divide by 100 somewhere. Maybe you actually got an answer in cents. You know, if you were out trying to buy, I don't know, like some school supplies in US dollars, not in pesos, then it shouldn't be coming out to 412, right? It should maybe be $4.12. So just things like that. It's always useful to be as specific as you can with your let statements. Now, with that out of the way, the trickiest part of the word problem, and we're going to get to this a little bit later, the trickiest part of solving these word problems is figuring out what your two equations are. And part of the fact is just it's hard to look at the words and figure out what the numbers are supposed to be, but it's especially hard when you have to do that two separate times in the same problem, right? So that is absolutely the trickiest part. Now here, what we've got is, I'm going to call this equation 1. So maybe I should actually mark that in somewhere. I'm going to call this guy right here equation 1. And this guy over here is equation 2. So in equation 1, I've written 5h plus 7r equals 36. Now, where did I get that from? So this 5h, what is h? H is how much it costs to play one game of air hockey, right? So this is 5 times the cost of one game of air hockey. So that's like the cost of 5 games of air hockey. And that's coming from this right here. So 5 games of air hockey, that's 5h, right? Because h is the cost of one game of air hockey, but it wasn't one game, it was 5. So that's 5h right there. And then in addition to it, so this and, it's pretty obvious, but the and is most likely going to be a plus sign in almost every situation. And then we've got 7 rounds of the racing game. Oh, my thing didn't draw there. 7 rounds of the racing game. So that's this 7R right here, because R is the cost of one round of the racing game, but it wasn't one round, it was 7. So it's 7 rounds of the racing game, so that's 7R, and plus 5H, 5 games of air hockey. So that's where we get this 5H plus 7R equals 36. Where's the 36 coming from? That's coming from this right here that says it costs 36 tokens to do all that other stuff, right? To do this 5 games of air hockey and 7 rounds of the racing game. All of that was 36 tokens. So that's this bit down here. That's equation 1. I just wanted to go into that bit of detail because that's the trickiest part of solving these problems. So, pardon the sound of the fridge. So that is, I wanted to go into the detail of how I was pulling those numbers out. So it is something that just comes with practice, and that's why I want to go through these questions with you guys so that you get that practice, but I also wanted to explain where I was pulling those numbers from. Now we also have equation 2 over here, h plus r equals 6. Now where's that coming from? So H, without any other numbers, so this is like one game of air hockey, H being the cost of one game of air hockey. So this is the cost of one game of air hockey plus one round of the racing game. It's only one round because there's no other number in front, right? So one game of air hockey plus one round of the racing is 6 tokens. Where's that coming from? Here we are. The cost of one game of air hockey and one round of the racing game is 6 tokens. So that's where equation 2 is coming from. And the question is, how many tokens did each activity cost? So basically, it's asking you to figure out what H is and what R is. That's it. So I'm going to isolate one of the variables in equation 2, just because that's a little bit easier. So I've just picked R. It could be H, could be R, doesn't matter. I'm going to isolate R. So in order to isolate R in equation 2 over here, I have to subtract H from both sides. So I get R equals 6 minus H. And then what we're going to do is, now that we know that R can be written as 6 minus H, we're going to plug that right into equation 1. Remember the equation that we didn't start with? We're going to plug this thing, this 6 minus H, anywhere that we see an R. So looking at equation 1, we've got an R right there attached to the 7. So I'm going to rewrite equation 1, but instead of writing 7R, I'm writing 7 multiplied by 6 minus H in the brackets. And if you remember the distributive property that we talked about, 7 times 6 minus H, you're going to do 7 times 6 separately. You're going to do 7 times H separately, and then you're going to leave that minus sign in between. So that's what we get down here when we're solving for H. 7 times 6, this bit right here, 7 times 6 is 42, that's this. And then 7 times H is 7H, that's this guy. And we just keep that minus sign the same right there. So this is what we have right here. We've got 5H plus 42 minus 7H equals 36. And now it's just a matter of doing a little bit of rearranging. So this this equal sign turned into a right arrow thing, that just means I'm going to the next step without going down to the next line. So that's just to save myself a little bit of space here. But all I'm doing from this step here to this step here is I'm just moving a couple of things around. So what I'm going to do is I'm going to subtract, let's see, what order do I want to do this in? Let's say I'm going to subtract 36 from both sides. So if I subtract 36 from the right side, 36 minus 36 is 0. And then on the left side, I'm going to say 42 minus 36 is equal to 6. So that's where this 6 comes from right here. And then what I'm going to do is, well, 5H minus 7H, that's negative 2H, right? So if I write out all this that we've got so far, so we did 42 minus 36 on the left side is equal to, so we subtracted 36 from the right side, so we had a 0 there. And then dealing with the h's, 5h minus 7h is negative 2h. So that's what we have right there. So 42 minus 36 is, whoops, it's not 36, it's just 6. 42 minus 36 is 6. And then instead of keeping the minus 2h there, I'm going to add 2h to both sides. And so we get 6 equals 2h, which is this guy right here. And then from that, you can divide both sides by 2, and you get h is equal to 3. So that tells you that one game of air hockey costs 3 tokens. Now I've just rewritten equation 1 and equation 2 here so that we don't lose them. But the last bit that we got from the previous slide, that's this whole thing, h equals 3, right? 6 equals 2h, h equals 3. One game of air hockey costs 3 tokens. So now we take that result, h equals 3, and we're going to plug it back into equation 2. So wherever we see an h, we're going to write a 3. So we get 3 plus r equals 6. And if you solve that for r, you're going to get that r equals 3. So last step, and you can't forget this because you will lose a mark if you forget this, It's what I call a communication mark. So it's if you're given a word problem, you have to give your answer in a sentence. If you're given a math problem, you can answer with math terms. You can write r equals 3 and be done with it. But because I've given you a word problem, I require that you answer it in a full sentence at the very end. So you figured out that h equals 3, you figured out that r equals 3. You just need to write a sentence. Therefore, that's why we call it a therefore statement. Therefore, and then just tell me those two things. Tell me h equals 3, tell me r equals 3, but use the words that you used in your let statement, or if they're the same number, then you can write it like this. Each activity costs 3 tokens, right? I'm answering this question that was asked at the end of the word problem. How many tokens did each activity cost? Each activity cost 3 tokens. So that's all you have to remember to write the let statement, write the therefore statement. Those are small things. I'm not going to make those count for a lot of marks, but really the hardest part is figuring out what your two equations are going to be, and then just remembering the order of the steps to go through the problem, which I realize that's most of the problem, and I'm saying that's all the hard stuff. It's not. If I had to rank the different parts of the problem, so you've got 4 different parts to these questions. You've got the let statement, you've got figuring out the equations, you've got the order of the stuff you have to do to figure out the 2 answers, and you've got your therefore statement. Figuring out the equation is the hardest part. The 2 equations that you're going to use to solve the problem, that's the hardest part. Actually solving the problem, that's the second hardest part. And then your let statement and your therefore statement, you just have to remember to write those in. That's all. There's nothing hard about writing them. You just have to remember to do it. That's the hard part, is remembering to do it. So that's it for word problem 1. All right, word problem number 2. This is the second and final one we're doing today. Scientists discover a solar system with 2 planets. You could fit a few Earths inside the smaller planet. So what I mean by that is, suppose you've got Earth is like yay big, and then you've got the smaller of these 2 planets is like yay big, and the bigger of these 2 planets is like yay big, for instance, right? So what I'm saying is you could fit some of this guy, this is Earth, right, inside the smaller planet. So you could fit like 1 Earth, 2 Earths, 3 Earths, 4 Earths, and so on, right? You could fit a whole bunch of Earths inside the smaller planet, and then you could fit some number of Earths inside the bigger planet as well, right? I'm just going to make that a smiley face, because why not, right? So, what am I saying here? You could fit a few Earths inside the smaller planet. So I'm not telling you how many. I'm telling you could fit some number of Earths inside the smaller planet. The other planet is twice as big, by which I mean that however many you can fit inside the smaller planet, however many Earths you can fit inside the smaller planet, you can fit twice as many inside the other planet. So if you can fit 10 in here, you can fit 20 in there. If you can fit 50 in here, you can fit 100 in there. That's all I'm saying. Now I'm saying if you could fit 24 Earths inside the 2 planets in total, how many Earths could you fit inside each one? So what I'm saying is these little red dots, suppose there's 24 of them in total between this guy and this guy. There's 24 of the little red ones. And there's twice as many of them in here as there are in here. How many do we have in each planet? So that's the question. And you've got the translation there. So I'll give you a few seconds to pause, a few minutes to think about it, talk about it, and then try solving the problem. All right, so let's get into the solution to this problem. So once again, it's a word problem. We haven't been given that we have to use these letters to solve the problem. So I'm just going to pick 2. I'm going to pick P for planet, and then Q for it's the letter right after P, right? So let P represent the number of Earths that you could fit inside the smaller planet, and Q the number of Earths that you could fit inside the larger planet. So again, nothing complicated here. You just need to figure out which letters you're going to use and come up with your let statement. Now, the hard part, figuring out the 2 equations. And once again, I didn't number them beforehand, so I'm going to do that now. Equation 1, that does not look like equation 1. I don't know what, that's not a circle. So let's try that again. Equation 1. and equation 2. All right, so let P represent the number of Earths you could fit inside the smaller planet. Cool. And Q the number of Earths you could fit inside the larger planet. That's the let statement. Now, the two equations. This first one, P plus Q equals 24. What's P? P is the number of Earths that you can fit inside the smaller planet, right? So the number of Earths that you can fit inside one of them, and Q is the number of Earths that you could fit inside the other one. So the number that you can fit here plus the number you can fit here is the total number of Earths that you can fit inside these two planets. That's this guy right here. If you could fit 24 Earths inside the two planets, so that's inside the two planets in total. So that's the two planets in total, the number of Earths that you can fit inside the two of them in total is P plus Q, right? The number that you can fit in one of the planets and the number that you can fit in the other, P plus Q. And that's going to be equal to 24 Earths inside the two planets. So that's equation 1, P plus Q equals 24. Cool? Now this other equation, Q equals 2P, where's that coming from? So let's draw out the two planets. And by the way, on your test, if you think it'll help you to draw out a diagram to understand what's going on, you're more than welcome to do that. All right, so suppose these are our two planets, right? Whoa, I don't know why that happened. Let's try that again. There's our smaller planet, and there's our larger planet. All right, so P is the number of Earths that we can fit inside the smaller planet. Q is the number of Earths that we can fit inside the larger planet. And I'm saying the larger planet is 2 times the smaller planet, right? This guy is 2 times the smaller planet, right? Now, the smaller planet is P, right? P Earths you can fit inside the smaller planet. So if the bigger planet can hold 2 times as many Earths, well, that means that Q is equal to 2 times P. All right, did you follow that? I hope that makes sense. I hope I'm not going too slowly. I can't see your faces. I can't say, did that make sense? And everybody nods and we just move on. So I want to make sure that everybody understands where I'm coming from, right? So once again, we don't know exactly how many Earths we can fit inside the smaller one. We just know that if it's 3 inside the smaller one, it's going to be 6 inside the bigger one, right? That's what the whole point of this statement right here was, right? The other planet is twice as big. So if it's 3 in the smaller planet, it's going to be 6 in the bigger planet. If it was 10 in the smaller planet, it's going to be 20 in the bigger planet, right? Now, basically what we figured out from this line right here, the other planet is twice as big, is that the number of Earths that you can fit inside the larger planet, Q, is going to be 2 times the number of Earths that you can fit in the smaller planet, P. So Q is equal to 2 times P. So that's equation 2 right there. Now, the nice thing about this problem is that Q is already isolated in equation 2. So I'm just going to take that answer, Q equals 2P, and I'm going to plug it right into equation 1. Now, equation 1 was P plus Q equals 24. So instead of P plus Q, in place of Q, I'm going to write 2P. So P plus Q becomes P plus 2P equals 24. And then if we just add those together, P plus 2P, that's 3P equals 24. Divide both sides by 3, and you get P equals 8. So from this, we figured out that the number of Earths that you can fit inside the smaller planet, that's what P is, right, is going to be 8. Now, with that, we have to take that answer, which we got by using equation 1, and we're going to plug it into equation 2. So just once again, on the previous slide, we found P equals 8, and here's just the two equations written out more properly again. So P plus Q equals 24, that's equation 1, and Q equals 2P, that's equation 2. Now from equation 1, P plus Q equals 24, we got that P equals 8. So we take that result and we plug it back into equation 2, So we get that Q equals 2P. Well, P is 8, so Q equals 2 times 8 is equal to 16. Q is equal to 16. And then we just need to remember that we have to write this out in words. So we know that P is equal to 8. What's P? P is the number of Earths that you could fit inside the smaller planet, and Q is the number of Earths that you could fit inside the larger planet. So the therefore statement becomes, therefore you could fit 8 Earths inside the smaller planet and 16 Earths inside the larger planet. And then of course you can double check. If you say that P is equal to 8 and Q is equal to 16, you can plug those into equation 1. You get 8 plus 16 equals 24. That is true. And then over here in equation 2, P is equal to 8, Q is equal to 16. That's 16 is equal to 2 times 8. That's also true. So it's always useful to do that little check, and then you'll be certain that you did the problem right. And so that's it for the word problems. Now, one last thing, I kind of already said this before, but when it comes to approaching these word problems on the test, obviously this is going to be an algebra test, so you're going to have some word problems that you just need to figure out one equation and one variable. Some of them you're going to have to figure out 2 equations and 2 variables. And I'm going to try and be nice and communicate which ones are 1 variable problems and which ones are 2 variable problems. But anyway, obvious thing, pay attention to the numbers. If I tell you 16 of something, 4 of something, 25 of something, that's probably going to show up in the equation. Now, the numbers that wouldn't show up are things like it's 12 o'clock, right? Or it's the year 2024, right? Those kinds of things, if I put those numbers in there, I'm probably trying to throw you off. Unless the question is about time, I might throw in those numbers, right? Of there's, it's 12 o'clock on a Sunday. That's not useful information if the question is how many apples and how many oranges did you buy? It doesn't matter that it's 12 o'clock on a Sunday. That's me trying to confuse you, right? If I tell you it's 12 o'clock on Sunday, May 15th, 2075. I don't know if that's the right day of the week, right? But if I give you a bunch of numbers, I tell you the time, I tell you the date, I tell you the temperature, but the question is how much did the books cost? That's me trying to throw you off. Now I'm going to try and be nice and not throw you off too much, but I might sprinkle it in somewhere because I like to do that. So generally speaking, pay attention to numbers. If I tell you there's 4 of something, 10 of something, 85 of something, if I tell you there's a fraction of something, if I tell you something is half, a third, a quarter, right? Sometimes I'll write those out as fractions, 1/4. Sometimes I'll write down the word quarter, right? So you have to be watchful for words that mean numbers as well. Things like half, quarter, double, triple, right? That's 2 times and 3 times, things like that. And like I said before, the hardest part is figuring out what your 2 equations are going to be, right? Now, I should have really said what the equation or equations are, because this applies to 1 variable word problems as well. But speaking about the 2 variable problems, because that's what this lesson is about, once you've figured out what the 2 equations are, it's all about trying to turn each of them into a 1 variable problem, because that's a lot easier to solve. All right, so hopefully that gives you a good sort of broad foundation of how to approach these problems. So in the past couple of lessons, we've talked about the different steps you need to follow to solve these problems. We've talked about BEDMAS, we've talked about exponents, we've talked about how to solve problems with 1 variable. We know what variables are. We know how to solve all of this piece by piece, right? It's just about making sure that we can put it together and that we can do it on the test when we're a little bit stressed, when the time is short, right? You got one eye on the clock, one eye on the paper. I know it's tricky. So that's why I'm trying to set it up this way, so that if it's something that if I make the test a little bit too long and you don't finish on Tuesday, you have time on Thursday, right? I don't want you to worry about the time. I want you to worry about the math, right? And actually, I don't want you to worry about the math. I want you to find the math so easy that you breeze through the test and everybody gets 100, right? So yeah, that's all there is to it, and hopefully this will be enough of a basis for you to get started with your studying, and then in the 2 review sessions we can talk more about how to solve these problems. So yeah, just a quick reminder, the 2 review sessions. The first one will be this Thursday at 8 p.m. Dominican time, which should be the same time for me. I'm only saying that out loud so that I hopefully don't forget it. And then the second one will be Monday, the night before the test. That's just like your sort of emergency, like, oh my God, I didn't realize the test was tomorrow. I didn't study this topic yet. I need help. That's what I'm there for. That last night panic before the test, that's what I'm there for. So that'll be 8 p.m. to 9 p.m. Dominican time as well, which, again, to say it out loud for myself, will be an hour earlier for me because I won't be in the same time zone. If for some reason I'm not able to make it to one of those review sessions or either review session, I will absolutely let you know as fast as possible. There'll be an Instagram post, there'll be a YouTube video if possible. I'll let one of your teachers know. I'll let one of your, I don't know, former classmates know. I'll let somebody know so that you guys know if a review session is canceled or rescheduled or what. Cool. Yeah, and that's about it. So good luck with your studying as you get started on that. On Thursday, we will have a test review, and then we'll have our review sessions, and that'll be that. We'll do our test, and we'll be done the algebra unit, and then we'll get into a bunch of fun math for the end of the school year. All right, have a good one.